Ciao friends! With the introduction of composite models, DAX has been enriched with specific features that are needed in order to make composite models over analysis services to work. This includes the define table and define column. I speak in another video about the define column statement. The goal of this video is to talk about the define table statement, the capability of creating calculated tables that exist only for the lifetime of a query. So a calculated table that behaves the same way as a calculated table in the model, but it is not persisted in the model. It exists only for the lifetime of a query. Columns in this table will have their own lineage, so you can use this table as if it was a regular table in the model, with the difference that it exists only for the lifetime of a query. Calculated tables in queries come with several limitations, so we will need to discuss them in order to understand when to use it and when not to use them. Let's get started. I have our regular Contoso model here, but in order to use the new define table statement, what I need is a query. Indeed, if you want to create a query calculated table, you need a query. That's why the first thing that we do is run DAX Studio and start writing a query. Let's leave some space for the code. Now, let's pretend that we want to create a new table that contains the brand, the color, and the sales amount. So it's a new table that we could create as a calculated table in the model, but we want to do that inside the query. We need to start with the define table, and then we need a name, colors, brands, and sales. What follows is a table expression that contains the code. So we can use a summarize columns by product brand and by product color, and we create a new column amount, which is the sales amount. Now this is just a regular table, a calculated table that I can use. Being a calculated table, it has its own lineage, so I can write evaluate and then use summarize columns and group by color, brands, and sales, colors, brands, and sales, brand. And I can also create a new column like total amount, and I can use sum of. Now, sum works with columns that belong to the model, but it also works with columns that belong to calculated tables that exist for the query. So I can write colors, brands, and sales. I'm missing an S here, color, brands, and sales, amount. If I did everything correctly and I write this and I run this query, you see that the result contains the brand and the total amount. So I'm using summarize columns over a table that is computed inside the query. The syntax is very neat because I can use the table name, the column name, and I can treat those columns exactly as if they were regular columns. With that said, calculated tables come with limitations. You cannot do all the operations that you could have done in calculated tables. The first of these limitations is that you cannot use a calculated table as the source for another calculated table. A calculated table cannot reference neither directly nor indirectly another calculated table. Let's see that. If I take this code that right now works and I use it to define a new table, I write a table, let's call it brands and sales, and then I write evaluate brands and sales. Now in the definition of brands and sales, I am using colors, brands, and sales, which is another calculated table. This is not allowed. If I run this query, all what I obtain is an error that says that the table color, brands, and sales cannot be used in the current context because a base table is expected. You cannot use a calculated table as the source for another calculated table. There is also another limitation. You cannot define columns on these tables. If you try to, let's use this again. No. slower. Let's copy this. Let's say that I want to define a column like total amount, which is no, let's column a color brands and sales is large amount. That checks if color brands and sales amount is greater than 1,000. Large, otherwise small. That should be an if statement. So I have created a new column in the colors, brands, and sales table that checks if the amount is greater than 1,000. It's large, otherwise it's small. But this is not allowed. I cannot define a column in a table that has been previously created as a calculated table. If I try to run again this code, it says that it cannot find the table colors, brands, and sales. Even though the table has been created a few seconds earlier, it simply does not work. So calculated tables come with several limitations, and you need to pay attention to them in order to use them. Besides, there is another important point regarding calculated tables, query calculated tables, that is important. They have their own data lineage. They do not have the same lineage of the columns they come from. Therefore, a calculated table in a query does not have relationships with the remaining part of the model. Let's see that with an example. Let's start again from scratch. Let's say that I define a table that I call colors, where I store values of product color. And then I want to use this table to add a new column that contains the sales amount. I can do that doing evaluate add columns to colors amount, which is sales amount. Now, when I run this query, what would you expect as a result? Let's format the code. Because colors contains values of product color, I would expect amount to compute the sales amount of the given color. But we need to remember that colors is a calculated table that has its own lineage. Therefore, the column color inside the table colors is not the same color in product colors. Indeed, if I run this query, you see that it shows the grand total everywhere. So there is a big difference between variables and tables. A variable keeps the data lineage of the columns that you are using to define the variable. A table does not. Let's see that with a further example. I have my table colors. Let's define a variable colors. And let's call it these T colors and these V colors. Now, if I use add columns of T colors, you see that I have an error. Define var V colors. If I use T colors, I still have the grand total. If I use V colors, I have the amount of the given color. So using a table or using a variable leads to a very different result. And you need to pay attention to data lineage also when you try to merge together these tables. Let's say, for example, that I want to generate a new table that contains both the amount coming from this query. So I can have this code and this code, one coming from T colors and the other one coming from V colors. I run it and I have two results: color, an amount, another color, and another amount. Let's call this amount from table. I need two different names, and amount from variable. So amount from table and amount from variable. What I want to do is create a new table that contains color, amount from table, and amount from variable all together in a single result set. I can do that. There is natural left outer join that does it. So I can evaluate the natural left outer join of this table and this table. I would like this to work and to build a join based on the color columns, but if I try to run it, I have an error. Why that? Well, again, the problem is the data lineage. In tcolors, the column color has its own lineage, whereas in vcolors has the lineage of product color. So if I use add columns this way, that is not going to work. I cannot join the two tables together. What I need to do is use, instead of add columns, use select columns in order to break the lineage. So if I replace that with select columns from tcolors, I take my column amount from totals, amount from table, and I add the color, which is product color. And I do the same here, but I start from vcolors. By the way, in vcolors I need to use product color. In tcolors I cannot use product color, I need to use tcolor colors. If I run the query, I will still have, well, apart from this comma, I will still have an error because I have not yet broken the lineage. But now I can do that. I add an empty string here, an empty string here. Now this color has its own lineage. This color has, again, no lineage, so I can run the query and I obtain the result, which is wrong. Yes, because I'm using amount from table in both places. This needs to be amount from variable. And now I have amount from table, amount from variable joined correctly using the column. So I need to pay attention to the data lineage whenever I work with calculated tables. As you have seen, you can now use the define table statement to define calculated tables that exist only for the lifetime of a query. It's a very nice syntax. It leads to very clean code because you can use table name and column name as if you would do with a regular table in the model, but there are several limitations. The tables created in this way cannot reference each other, so you can only create one level of tables. And the second point is that these tables, they do have their own data lineage. Therefore, they do not have relationships with the remaining part of the model. And because you cannot create relationships which are local to a query, this strongly limits the usage of calculated tables inside your code. But if you can live with this limitation, they are a great tool that you can use when writing DAX queries. Enjoy DAX!